In this lesson, we're going to review how to solve linear systems, a skill you learned how to do back in Algebra 1 and will continue through pre-calc. So, just a quick reminder, when you're solving a linear system, if you think about what the graph could look like, so it's possible that you have two lines that intersect when you graph them. So the point of intersection is going to be your solution to the system because it's the one point that satisfies both. So your solution is going to be written in the form of an ordered pair. Now it's possible you have some special cases where the lines are parallel and they have no point in common, or you have one line and a second line that falls directly on top of it where there are infinitely many solutions in common. You learned three methods for solving a system back in Alg 1. Graphing, substitution, or elimination. So I'm going to review one of each, and let's start with graphing. So when you graph, you can find your x and y intercepts, but typically learners prefer to change both to slope-intercept form. So I'm going to solve each of these for y. So the first one would be 3y equals x plus 3 if I add x to both sides, and then if I divide by 3, that's going to give me a slope of 1/3 x plus 1. Right? The second one would be y equals negative 2x plus 8. So I'm going to graph each of these in the coordinate plane below. So that blue line crosses the y-intercept at 1 and has a slope of 1/3, so I went up 1, right 3. The green one crosses at positive 8 and has a slope of negative 2, so that would be down 2, right 1. And I repeat that, and I can see right there where those two lines intersect. Okay? So that's the point that's in common to both. So make sure then that you state what your solution is. As an ordered pair, it's the point 3, 2. Now, one drawback of the graphing method is if you have really large numbers or decimals, or what if the intersection point is not at two integers? What if it's at a third or a fifth? That's really difficult to see on a coordinate plane. Of course, if you have a graphing calculator, that's a great solution, but we have two other more algebraic methods. So the second method is substitution. So with substitution, I typically do this if one of the equations is already solved for one variable. But if it's not the end of the game here. So what you can do is I'm going to take this second one because I noticed that the coefficient on y is -1, and I'm going to solve this for y. So if I subtract 5x from each side, I'd have negative 5x plus 14, and then if I divide by -1 would give me y equals positive 5x minus 14. And what you're going to do is you're going to take this expression here, 5x minus 14, and everywhere there's a y in the other equation, you're going to plug in that expression. So in place of the y, I put 5x minus 14, and now I have an equation in just one variable that I'm going to proceed to solve. So I start by distributing. I get 15x minus 42 equals 9. Combine my like terms, I have 17x. I'm going to add 42 to both sides, equals 51. And I divide both sides by 17, and I get x equals 3. So as far as my solution, I'm halfway there. Remember, x, y, as far as your solution. If they ever use variables that are not x and y, common practice is just to alphabetize. So what I do now is back in the expression, or the equation right here that I originally solved for y, the 5x minus 14, I'm going to plug the 3 in now. So I get that y is equal to 15 minus 14 would be 1. So I know that these two lines, if I'd done it by the graphing method, intersect at 3, 1. The third method for solving a system would be elimination that you learned in a previous course. So typically I use elimination if my two equations are in standard form. And what I'm trying to do is I'm trying to create opposite x terms or opposite y terms, and I'm going to go for the y's right here. Okay, so 2 and -5. If I multiply this top equation by 5 and the bottom equation by 2, I'm going to create terms of 10y and -10y. So that produces, when I multiply the top one, 7.5x plus 10y equals 100, and the bottom one would be 5x minus 10y equals negative 50. And now what I do is I stack and I add these equations. So that's going to produce 12.5x. These two terms are eliminated, which is the whole point of this method, equals 50. And now in black here I have this very simple equation where if I divide both sides by 12.5, I get x equals 4. So halfway there. Now you can't avoid substitution altogether. You're going to go back to one of your original equations here and substitute this 4 in for x. So I'm going to plug it into the top one, which produces 6 plus 2y equals 20. So if I subtract 6 from each side, I get 2y equals 14. Divide by 2 and I get y is 7. So these two lines intersect at the point 47. That's the solution to my system. Just to remind you of the 3 scenarios that could occur, we just did 3 examples where we had one solution, but algebraically, if you work it out and your variables drop out, and you have a true statement, something like 4 equals 4, 7 equals 7, that's where you have coinciding lines and there are infinitely many solutions. Where if your variables drop out and you get a false statement, that is indicating parallel lines and there would never be a solution. Okay, so here's your overview of solving systems. If you need more help, please reach out with questions.